All right, good morning, Tigers. This is going to be your first video for the Unit 2A practice test for your unit test on functions. So we're just going to go ahead and jump right in. All right, so number one, determine if the given relations are functions and explain. So if you remember, the definition of a function is that each input has one and only one output.
Teachers, please update your attendance at this time.
Sorry about that. So each input has one and only one output. So if I look at A, this table or this bubble on the left are my X's or my inputs, and the bubble on the right is my Y or my outputs. So I want to make sure that each input only pairs with one output. So when I get to the number 5, it pairs with 3 and 5. So no, this is not a function. The input 5 has 2 outputs. All right, so let's look at B. So what I'm going to look at on B, since it's a table, is we're going to make sure that each variable, or I'm sorry, not each variable, each input only appears once in the table. So we have 1, -3, 5, -1, 4. So I only have 5 inputs, and they're each only used once. So yes, this is a function. For your explanation, you could just say each input has one output. All right, and then C. So this is a graph, so we need to check to see if it passes the vertical line test. So I should be able to, draw a vertical line anywhere through this function, and it only touched the function at most once. But when I get to about here, if you see, my little clothespin touches 1, 2, 3 times, so it's not a function. So if I draw a line here, and that's not a very pretty vertical line, but you get the idea. No, it fails the vertical line test. Okay. All right. Number 2, domain and range. So if y'all remember, I think my class knows this. I've made a poster in my class for my domain and range for my kiddos. Domain is your X. You're looking for the point the furthest on the left to the furthest on the right. Okay? Range measures your Y's, and you want your lowest point to your highest point. Okay? So you can fill that in for domain and range every single time. So domain, I'm going from left to right. So my point furthest on the left of this is -3, and my point furthest on the right is +3. So we're going to say that the domain, let's do this correctly. We're going to say that the domain of X is that X is between -3 and +3. Okay, and we're going to look at range now. So we're going to go to my lowest point, which is -2, to my highest point, which is +2. Okay. All right, and then we're going to use that same little template to fill in part B. I'm going to move this over here. If you need to see that answer again, you can always rewind. All right, so domain from left to right. So if I keep going to the left, see how it has this arrow? So it's going to continue. Not only is it going to continue going up, but it's going to spread out and keep going to the left. And it's going to do that forever. So my domain is going to go all the way to negative infinity. And then going to the right, same thing. It's got that arrow, so it's going to continue to go up and to the right. So it's going to go all the way to positive infinity. I'm sorry, that is ugly, but you get the idea. Okay, range. Okay. My lowest point is -4. It does not go past that -4. That's the lowest it goes, and it turns around and goes back up. So -4 is my lowest point. But going up, it goes up forever because of those two arrows. So it goes up to positive infinity. Okay, so if you were in Miss Paflin or Miss Means' class, or even in my class, we did this in my class too. Instead of saying from negative infinity to positive infinity, you could say that X, or my domain, is all real numbers. I'm abbreviating because I'm writing in tiny spaces. You could say that the domain is all real numbers. You could say the range is just that Y is greater than or equal to -4. Either one of those are fine. I just find that if you have your little template, it's easier to fill in. It's easier to fill in, hey, I go, what's the furthest left? Hey, what's the furthest right? It's easier to me, but you do you. You do whatever's easiest for you. As long as you get it right, I don't think we care which way it's written. Okay. All right, so let's go on to number 3. This one's another domain and range. The difference with this one, though, is this is a discrete function. We're only given a few points. So let's look at my domain for this one. So my domain, I only have 4 points. I'm just going to list those 4. So we have 4, 6, 0, and -5. Okay. My range, I'm just going to list these 4 points. 9, 13, 0, and -9. We don't know any more about that relation, so we can't list anything other than what we're given. All right. Number 4. Identify whether each graph represents a function. If the graph does represent the function, or a function, is the function linear? So we're defining 2 things. Is it a function, and is it linear? So let's look at graph A. So first thing I want to do, since we're determining whether or not it's a function, we want to do the vertical line test. And if I pass my little clothespin through, it touches that quadratic at most once. Like it doesn't touch at 2 spots on the same time. So this is a function. Now the second question is it linear? Which is an easy question. Is this a straight line? And no, it's got this U shape to it, so it's not linear. Actually, we already said what it was. We said it was quadratic because it has that U shape. It didn't ask for that, but if you just want to feel smart and put it down, you certainly can. All right, number 2. So I don't know if you can tell, these lines with the arrows are the axes. This is the relation in question. So is this a function? Well, if I take my clothespin and run it along the function, it only touches it once at each point. So yes, this is a function. Each x only has one y. Is it linear? Well, is it a straight line? Yes, so we would say it's linear. Okay, and then part C. We're looking at this line. Now, if I were to run my clothespin through, my clothespin is touching at 1, here, let's bump it up, at 1, at 2, at 3, at -1, at -2, at -3. It's touching that whole function right there. So, well, that whole graph, because it's technically not going to be a function. So it's not a function. It does not pass the vertical line test. Is it linear, though? And it does make a straight line, so it is linear. but it isn't a function. So, yep. All right. Okay, and again, if you need to spend a minute, feel free to rewind and rewatch parts of this video. Feel free to pause it to write stuff down. I'm going to keep going though. So we're going to go on to, we're going to probably end this video after number 9. So let's go ahead and do number 5. Number 5 is just asking us to identify the independent and dependent variables. Remember, the dependent depends on the independent. Okay, so A, Taylor turns the garden hose on to fill up her pool. As time passes, water fills the pool. So does how much water does how much water there is in the pool depend on how much time has passed? Or does how much time has passed depend on how much water is in the pool? Time depends on nothing but itself, okay? So our independent variable is going to be time, and our dependent variable is going to be the amount of water. All right, part B, this should be easy because it's a graph. So if I want to identify my independent and dependent variable, remember X, or your horizontal axis, is always independent. So here we have distance in miles. So my distance is the independent variable. Cab fare in dollars is the dependent variable, which makes sense. Like how much you're going to pay your taxi driver depends on how far he takes you. So makes sense. All right, 6 through 9. Number 6. And we're using the graph for all of these. So number 6, identify the y-intercept of the relation. So the y-intercept is where my graph or my function crosses the y-axis. So here's my y-axis. Here's where it crosses. So a lot of people are just going to write -3 and be done. But the y-intercept is always a coordinate. My x here is 0, my y is -3. So I want to make sure I write it correctly. All right, number 7, domain and range of the relation. So you can use your little template again. In my honest opinion, when you make your note cards for this unit test, I would seriously put this on there. Like, that's going to be super important. Okay, number 7, identify the domain and range of the relation. So domain, again, furthest left to furthest right. So if I look, my point furthest to the left would be right here at -9. My point furthest to the right would be +8. So my domain goes from -9 to +8. Okay, my range, we're going to go from the lowest point to the highest point. So my lowest is down here at -9. My highest is right here. It's right above 0, but we're just gonna estimate and say it's 0. All right, so my range goes from -9 to 0. Okay, so left to right, lowest to highest. All right, 8, identify any relative maximums and relative minimums. Okay, so maximums, we want any of these little top points that are higher. Now remember, relatives cannot be endpoints, so we just want these top points. So we have one at 0, and again, we're only listing y coordinates. And we have a maximum at -2. And then if we want our absolute maximum, we'll do maximums at the same time. Our absolute maximum, our absolute highest point is that 0. Okay, my minimums. Okay, again, relative cannot be an endpoint, so we're just looking at these low points. We have one at -8, and then another one at -5. And my absolute minimum, my absolute lowest, is here at -9. So we're going to make a note right here, not endpoints. And here we're going to put possibly endpoints. A lot of people think that the absolute has to be an endpoint. It doesn't have to be, but it's possible. Okay, so I'm going to stop this video here. Again, rewatch it as many times as you need to, and part 2 will cover the next section. So thank you so much for your attention. Hope you have a good day.